Well, you guys are in for a treat.
I
taught this lesson this morning, and I realized, you know what, that really needs a bit of a tune-up. So I had a prep period right before lunch, and I did. I actually tuned up this lesson, so you guys are going to get the new and improved version. So that's pretty exciting, eh?
Sure.
So I mean it's harder?
No, it's probably better.
Oh, okay.
Better explained, just, flashier graphics, new and improved. So, I've left that up there for you a little bit. Subtraction vectors. We've talked about addition of vectors, and of course, the natural thing to follow after addition, of course, is subtraction. We will not be looking at division or multiplication vectors, and you need to be about second or third year university before that starts to make sense. Yeah, so you don't even want to go there. But subtraction, not that hard. It seems a little bit hard. I probably make it harder than it needs to be. There's a reason for that. When you get to grade 12, and I know you've heard this sort of thing before, but when you get to grade 12, it all sort of falls into place and makes a little bit more sense. Okay, so don't freak out if you don't get it right off the top. I'll do my best to try to explain it to you. Again, it might seem hard, it's not. I'm just sort of covering certain points that sort of maybe have to be covered technically. I don't know. Anyways, let's get right into it here. So, what do you think subtraction vectors means if I remind you that addition means placing it tip to tip?
Tail to tip?
It says maybe tail to tip. Why do you say that? Or are you just guessing?
I'm guessing.
Good guess.
It's all for the addition.
Good guess. Anybody else got any ideas? Maybe tip to tip?
I don't know, man.
Tough to say, right? Okay. Well, what I'm going to do is I'm going to walk you through it. I would consider these notes if I were you. Okay. Now, that doesn't mean you got to write everything down, but it certainly means.
Exactly.
It doesn't mean that. It certainly means paying close attention and writing something. Okay? Because this is sort of like a new topic, right? So yeah, subtract. Do you need to write any of that down?
No.
Do you need to write down what do you think it means in your notes?
No.
Please don't, God. Do you need to write down addition means place tip to tail?
No.
Not if you already know it.
Yeah, no.
Not if you already know it. We're going to start by looking at scalar numbers and how subtraction really works. Probably something that you never really thought about too much. You've all done subtraction before, perhaps, right? Maybe something like, where is it? Right there. 10 minus 6, would you agree is the same as 10 plus a minus 6? I think you would all agree with me on that. So, what's my next question, do you think? How do you, you're almost there, Connor. I said that negative 6 is the negative plus 6, so what's sort of the question that deals with vectors that goes along with that? How do you find the negative of a vector?
Different direction.
That's a possibility, isn't it, right? So there's the question, right? Subtraction of vectors can be done the same way. What is the negative of vector? Brett says? Opposite direction. And how did you come up with that? Yes? Makes sense.
Just placement. You go one way, you gotta go the opposite to the other.
Okay, well, even if we do this, right? Even if we think about, and you're right, a grade 10 sort of science kind of idea, right? Plus 6 would be that, and minus 6 would be that. And if you sort of look at it that way, you're right, opposite direction. But is that true for 2 dimensions, you think? Why wouldn't it? Why wouldn't it? So yeah, the negative of a vector is a vector having the same magnitude, but exactly the opposite direction. You can choose to write that down if you like. 5 minutes really nice. But it's really not a difficult concept. As Brett said, it's simply exactly the opposite direction. All right, so the negative of a vector is a vector having the same magnitude but exactly the opposite direction. Now, I don't know if you need to write this down or not, but there's vector A, so negative A would simply be,
The other way,
do I have it here?
to the left.
Pretty exciting, eh?
No,
It's pretty flashy, huh? What if it's like up and to the right?
it should be down to the left.
Down to the left. What if I give you the direction as a number? Like what if the number is 0, 1, 0?
Maybe it's gonna be like 190.
Well, now a little bit of thinking going on here. If it's 190, you say?
Thank you.
How did Kish go up with 190?
Exactly across.
What's the number that he used to get that?
180.
180, right? You hear that in people talking about pulling a 180, which means turn around and go
Oh,
other way, right? Now, did you add 180?
no, I can. Kind of.
Yeah, well, not
I
kind of.
did,
you did.
I did 180 and then I added 10.
Yeah, okay. Is that the same thing?
Yes.
Okay, 180 plus 10 is 180, but what if it's already bigger than 180? Like what if it's 300?
Then reverse it.
Subtract 180. Yeah, subtract 180, right? 120.
So pretty much if the number is above
Yeah.
180, then you subtract it to 180.
Add 180 or subtract 180, whatever you need to do. Yeah, pretty easy. What if it's something goofy like south 15 east?
And be north 15 west.
You just change the south to north and the east to west, did you?
45.
How about we draw that?
West, north.
South 15 east would be like south 15, right? East.
Yeah.
So the exact opposite of that would be like that.
Be north,
Wouldn't that? You're right. Wouldn't that just be
be north 15
west.
north 15 west? There really isn't anything to it, right?
see this, what the,
Doesn't that make sense?
flip the
Just change the direction. Will the number always stay the same? Like, will that 15 always be 15? It's not always going to be 15, right? But if it's
Whatever it
like
is.
25, does it stay 25?
Yeah.
Of course it is. Of course it is. Okay. So, yeah, if you want to grab the clickers, the correct answer, the best answer, is B, 10 meters per second west. Okay? You really shouldn't write minus 10 west, kind of as a double negative, you know? I didn't learn nothing.
So would that be the same as 10 meters per second west? Times 10 meters?
Say that again?
Would the D and the question be the same?
Yeah, pretty much, yeah.
why did you write me wrong?
All right, so here's number 2. Right, I would try not to do that. I would, yeah,
We only have one question.
I know. Okay, so here's the next one. If vector x is 25 kilometers an hour at north 30 east, what is minus x? Correct answer is D, 91% again, that's good. Right? All you do is what? Exactly, all you do is switch. North, 30 east, the north becomes south, the 30 becomes west. Okay, so we've already seen, we've talked about how to turn a regular subtraction question into an adding question. We add minus 6. We know how to find the opposite of a vector now. How do we subtract vectors? This is the key of the day. If there's one thing you're going to learn, it's this. To subtract vectors, find the inverse of the vector to be subtracted. In other words, flip it. And simply add it tip to tail to the other vector. Flip and add. That's all you got to do. In fact, we already know how to add. It's just I'm adding one more step, the flip. Now, it's going to be a little bit more complicated than that, but that's what it boils down to, really. Okay? And then we're going to do this one right away.
direction do you like stick it in?
I'm going to show you right away. Yep. So here we've got vector A. We're going to subtract vector B, right? A is up and to the right. B appears to be straight up, right? Okay, so the first step is to figure out which one do we need to flip. And the one that we're going to flip is
B.
the B, right? Why the B? Because that's the one we're subtracting, right? That's the one we're subtracting. I don't think there's anything for me to click on, no. Okay, so what that means is that negative B is simply going to be down like that. So now I'm going to add them tip to tail. So I'm going to take vector A, and I'm going to add minus B. Okay, and then I'm going to draw my resultant just like I did before from where I started to where I ended up. Okay, now as far as I know, like when you add numbers, you get the sum. That's the answer. It's called the sum. When you subtract numbers, it's called the difference. I haven't found the proper name for the difference of vectors. Okay, so we're just going to call it result. I don't know of another name. So we use R in both cases. I mean, it's really just an addition question. Is that good? Yeah? Good, good, good? Okay, so let's take it a little step farther, and let's put some numbers in there. Let's see if we can do it. Okay, so if A is 10 meters north and B is 50 meters east, what is A minus B? Do you want to try this one on your own?
Yes.
Just try that a little bit. Use a pencil. If you make a mistake, that's fine. We can erase or we can go to the side, okay? Don't worry about making a mess. Okay, so we've got 10 meters. Now, we know it's A minus B, right? So the one I'm flipping is this one. So 10 meters north is going to be my A. And I'm going to be a little bit over ridiculous on drawing everything out, right? Do I need to do all that? Yeah. Certainly don't need to, but I mean, it might be a good idea at this sort of beginning stage, right? And now I'm simply going to add, I'm going to go A, and then I'm going to go minus B, right? And this is 10, and this is 15. And so my resultant is there to there, right?
10 squared plus.
R squared is going to be 10 squared plus 15 squared. 10 squared is 100. 15 squared is 225. So R is the square root of 325, which is 18. Is it exactly 18?
18.02.
18. Okay. 18.0. Do I need anything else there, Aurora?
I don't think so.
No?
So you need the direction.
Ah. Where would I draw the theta? Would I draw it down at the bottom or would I draw it up at the top? Which one?
The way you have it right now.
Right here?
Yeah.
Yep. Right there. It's always where you start, right? Okay. Now it's a right triangle again, so I can use inverse tan. Opposite over adjacent, so 15 over 10. And you should get, what is it?
45 degrees.
No, it can't be 45 because it's 15 and 10.
84.
How much?
84.
84? No, wouldn't be that much. Maybe 68, maybe.
Still at 84.
I got 56.
Yeah,
56.30.
North 56, west, I believe. Pretty sure.
There you go.
Yeah, I got it. Remember, your calculator has to be in
Degrees.
degrees, right? I've had a few people in the morning class, their calculator wasn't in degrees, so it has to be in degrees. So that would likely be worth 3 marks, one for the 56, one for the 18, and one for the diagram showing the flip. Okay? You need to show me I know how to do vector subtraction. Okay? Are we good?
Do we, in our final answer, we have to do it like that, the north.
Yep, yep. Or rather than what? You mean like put the number in there? Yeah, I need you to know that it's north and west. Yeah. Yeah. Okay. Now, so that's basic vector subtraction. Okay. Now we're going to take another step and we're going to sort of apply it to sort of a real situation, not just sort of made up mumbo jumbo. And I'm going to go back and sort of thinking a little bit here. But first, I'm going to ask you a question. Vector A is 5 meters north. Vector B is 4 meters per second west. Which diagram best shows A minus B? What's the answer? 100%. All right. All right. Okay. So now let's sort of take that a little bit farther and let's talk about displacement. Displacement is a good example of a vector subtraction. It's the easiest one. It's the only one you're going to see. I think. Yeah, I think so. Okay. You don't need to write this down. I just need to sort of build up some basic knowledge. Right? Yeah. Kish has already got the answer. Here's a perfect example where the answer doesn't matter. An object is on a number line at an initial position of +3. It ends up at a final position of -3. Find its displacement. And as Matt has pointed out, it's clearly -6. We would call this my initial position, and that would be my final position. Okay? And the displacement is the difference between those. It's from there to there. Would you agree then the displacement is the final position minus the initial position? Right? It would be like, in this case here, it would be like -3 subtract 3 minus 6, right? Right? Okay. Is the same thing true for like a two-dimensional vector situation? I mean, could I make that into like a 2D kind of thing? Sure. I probably could. Let me just show you here. Don't write this down. Just sort of watch here, right? But like if I have like my initial position is like from there to there, and I'll go a different, and my final position is like there, right? And if I go xf minus xi, if I go xf and I add this, if I flip that, right? Subtract it by flipping it, and then add it, well, how long is that going to be? -6, right? Okay, so the vector thing is true as well. Okay, here's an example, and yeah, you really, really, really need to write this one down. So I'll wait for it. All right, I got a hunter here is at an original position of 500 meters east from his truck. So there's his Chevy Silverado down the bottom there. So he is that a Ford?
Yeah, it is a Ford.
Oh, okay. Yeah. Okay. I just Googled truck, and that was the first one that came up. Okay, so there he is there. Now, did he walk from there to there?
No, that's just starting.
That's just where he is. We don't know whether he walked there, he, jumped out of the truck and the truck kept going, or aliens abducted him and dropped him in the field there. We don't know, and we don't care. Okay? So what then?
Are you talking displacement from his truck?
I'm talking about his position. His truck is what we would call starts with an O? Origin. The origin, right? Like 0, 0 kind of thing, right? So he is 500 meters east of his truck. His initial position is represented by that blue vector. That does not mean he walked from his truck to there. Okay? It does not mean that. It just means he is 500 meters east. It's a vector representing that position. Now, a little bit later, he's going to be in black. He's going to be 750 meters north. That's going to be his final position. Now, did he walk back to his red truck and then walk north? No.
I thought he walked right from there up.
He did, okay? These are not walking trails. These are vector position vectors. Okay? Position vectors. Now, his actual displacement here in red is going to be from there to there. That is his displacement. Did he walk from there to there? That he did do. Okay? But this is not a walking diagram. This is a vector diagram. Looks a lot like a walking diagram. Okay? Now, it's important to sort of, this next step is kind of important, I think. Okay? I would like you to write delta D is final minus initial. Now, I had someone this morning say to me, we never used that formula. It's not really a algebraic formula, it's a vector formula. Like the displacement is a vector, and it's the final position vector minus the initial position vector. I'm not going to plug numbers in there. because I can't. They're not numbers, they're vectors. They're vectors. They're vectors, okay? And then I'm going to write delta D is final plus minus initial. And like that's not really necessary. It just shows to me that you get the idea of we're doing vector subtraction. Are we going too fast?
No.
No? Good? Okay. You did vector subtraction in grade 10? Yeah. Okay. Okay. Okay.
Do you talk to Paul for last class?
We'll see. All right. So now what I have to do, now this is not a diagram of vector subtraction. I have to do the flipping part. Okay? So I'm just going to do it up on the right-hand corner. Does it have to be to scale? No, because we're talking east and north. So I'm going to do, now remember it's final plus minus initial. So I'm going to put my final one first. I'm going to go like this. There's my final. And now negative xi is not going to be to the right, it's going to be to the left, minus xi, and now my displacement is going to be like that. Okay? So this is the vector diagram that shows vector subtraction. And now it's just a plain old vector addition question, and I'm going to write r squared is going to be 500 squared plus 750 squared, and you're going to solve that. And I don't remember what the answer is. No, but you will. $901.4? Is that what you got? 901.4 meters. Is that complete?
That makes no sense.
It makes no sense?
750 squared is more than 900.
But then I added 500 squared, and then I took the square root of it.
Oh, okay. Now we got it.
Yeah. Did I do it right? Anybody else do it?
Okay, now I just have to do it.
Yeah? Okay. Okay. Now,
I didn't know you rooted it.
you got, oh yeah, you got to root it, right?
I was
Put a theta in there where we start, and we're going to go theta equals tan minus 1, opposite over adjacent. Now my opposite is my xi, that's this one here, that's my 500 over 750. It's a common error to get those upside down, so it might be a good idea to draw them on your picture there. And you get an angle of, and someone's going to have to help me here, I don't know. I had it written down, but I threw those sheets away.
33.7.
Okay, can we say 34?
No, wait. It's 33.69.
That's still 34.
Yeah.
So that's going to be 34. Now that's going to be looking north, going 34 degrees to the
Left.
which is known as west. Nobody says north 34 left.
Left.
It only works if you're facing north.
I'll say left.
West, okay, yeah. Now, do you need this diagram? And I'm going to say yes. I need to see this so that you show me, Mr. Bennett, I understand vector subtraction. One kid asked me this morning, does it matter whether I put the 500 here or the 750 there? Does it matter what order they are there? The number's going to be the same, right? I'm not going to be checking that. Okay? Could I have done the whole thing without drawing that picture and just sort of done 500 squared and 750 squared and finding that angle? Absolutely you could have done that. It just wouldn't have shown me that you get vector subtraction. So if you want that mark for doing vector subtraction, I got to see this. Okay? Here's a question for you. A hiker is 1.5 kilometers east from a campsite, then walks for a while and is 0.6 kilometers south of the campsite. What is her displacement, and which diagram best shows the vector subtraction needed to solve this problem? So figure out which picture is the best one. Correct answer? I feel like I'm on Family Feud here. Correct answer is D. That's not so good. That's not so good. We better have a look at this. Okay. Which one is the initial one. Like hiker is 1.5 kilometers east from a campsite. That's the initial. Then walks for a while and ends up 0.6 kilometers south. So that's the final. So you got to go south first,
And
and then subtract the initial, which is now west. Now, hold on a second here. How many people put B? Why'd you put B? Just guessed? Would B be okay? Really what you've got here in B is you've got minus xi and then you're adding xf, which really is
the same thing.
the same thing, but you'll notice that the question says which diagram best shows. And I've shown you really should go xf minus xi. So D is the correct answer. If you put B, you'd be okay, but I wouldn't feel very good about it. Okay, so now I want you to actually do the question. Do the question. I'll let you know that number 5 is the length and number 6 is the angle. I'll give you a couple minutes to try that. I've given you the diagram already. You should be good to go, right? Correct answer is 1.6. Yeah, I'm going to guess a couple people maybe have like 1.5 something. Does it tell me? Okay, let's see the angle here. What's the angle on it? No. Correct answer is C.
What?
C. 1.5 east is my initial, right? This is my final, so I go south and then I go east, and so it's 0.6 and 1.5, so it's inverse tan of 1.5 over 0.6, and you should get south 68 west.
Keep thinking out.